So, day 4. You are only learning one new thing today. You have to learn how to draw a box.
No, but I already know how to do it.
Well, then you are extra ahead. Okay, dial the volume back.
Like a 3D.
Okay, so a lot of people in other classes have wanted their cheat sheet out as we've gone through the lesson because they don't remember all their implied statements. So if you want your cheat sheet out, you might get it out.
I'm gonna twist myself.
Okay.
On the implied statements, is it like doing the ones from last time? Maybe I can have it.
So to start off, we're just going to continue using our laws of syllogism and detachment to make logic chains. We're just going to keep chaining our implied statements together. So if you know your implied statements, anytime we do a proof, you're just going to be going back to stuff you've memorized. And so knowing those is going to make this go a lot faster because you're just going to use stuff you already know. So to start off, it says given CD is a segment bisector of AB. So first thing you want to do on anything is draw a pretty picture so you can picture what's actually happening. So go ahead and draw yourself a picture of ray CD being a segment bisector of AB. Okay? Now, AB is going to be just some random segment. CD is a ray. Where is C going to start? Do I know that?
Yes.
How do I know that? Did it say it? Well, yeah, but couldn't it have started down here and gone up through?
No, because it intersects at midpoint.
Well, yeah, couldn't this be a ray that starts down below?
At midpoint.
Well, yes, well, but how do I know C is the intersection point instead of down here?
Because segment bisectors are intersecting.
Yes, how do I know it's not starting down here at C and intersecting somewhere other than C?
Because it says AC.
Look at what you're trying to prove. AC has to equal CB. If they're going to be equal lengths, shouldn't they be the thing that got bisected? So they should be collinear, right? Which means C had better be in between them. That is your clue that C is here and not down below. You can't just look at alphabet soup. You have to think about what the stuff means. And so C is starting here and goes off somewhere else. Could it be going down? I don't know. Could it be perpendicular? I don't know. So draw it how you want it. As long as you meet these rules, you're good. That's the fun part about getting into geometry now is your picture can be looking any way you want, and whatever you say is true has to be true. Because you can't trust the picture. So you go, okay, what do you always get right at the start of a proof?
Given.
Given. So you start off with what you're given. So ray CD is a bisector of segment AB. Notice I did the shortcut way of writing it because I'm lazy. Could you write out this whole thing exactly? Of course you could, but I'm lazy, and I don't. And how do I know that CD bisects ray AB? Because it is given. You should always get the first two things correct. And oh look, in a flowchart proof, flowcharts have boxes, so you get to draw a cute box around it. I would wait to draw the box until you're done writing all your words so you don't run out of space to write your words. So now I'm going to use my chain. So now I got to chain something together here. And what you're going to do is you're going to look at this first thing and say, what was I talking about up here?
Segment bisector.
A segment bisector. And I'm going to think, where could that segment bisector lead me? What do they lead to?
Intersection.
Intersection at a midpoint. And see, I ran out of space, so I had to make my line a little longer. Okay? And so now to fill in my conclusion up here, I think if CD was the thing bisecting AB, that's the segment bisector, on this side, I need to say something about a midpoint. What do I know about my midpoint? It's named C. So I'm going to say C is the midpoint of AB. I used the implied statement to tell me what goes there. Now somehow I have to get all the way to AC equaling CB. Now all I've got is a ding-dang midpoint. So you have to start thinking of your implied statements. Where can that midpoint take me?
To collinear segments.
To congruent collinear segments. Now if I'm trying to get to AC equaling CB, do I care more about them being collinear or do I care more about them being congruent? Probably about them being congruent. So what am I going to say here? What are my two congruent collinear segments going to be? AC. And would I say it's equal?
Congruent.
I would say it's congruent because it's congruent segments.
And then we're done.
So it's congruent to CB. Am I done?
No.
Well, he said I'm done. Why am I not done?
Because it's not equal.
This isn't equals. I've only found a congruent. So I have to keep going until I say that exactly. Yes, what do you got for me, Luke? Oh, here I have a couple of congruent segments. What do congruent segments imply?
Equal length.
Equal lengths. It's just crazy. So Quentin, what two lengths am I going to say are equal?
CB and AC.
Wow, Quentin, you like threw your voice all the way over there. That was some skills. Can you keep it in your own mouth?
Oh, I can't.
Okay, try it. Let me hear it.
Okay, AC is equal to CB.
Wow, you are so skilled.
Thank you. Appreciate it.
And then you draw your cute box so nothing escapes.
Sorry.
Bless you. So you just did a flow proof. It's a flow chart. And the arrows, see how I drew an arrow telling me what box leads where?
It's not that bad.
That's all that is.
Why do you have to separate?
So, try problem number 2 then. Because of course everybody's wondering why have I got a whole lesson for this if it's stuff we've already done. And it's because there's going to be things that catch you, and I want to introduce you to the different things you might mess up or the different things you might encounter as you work them, so that if you start on your homework right now, you're going to come across those things and not have any idea what to do. And so I'm going to show you some of those tricks and tips and pitfalls and weird things that happen. So, yeah, look at number 2. Example 2, draw the picture. Draw the cute picture that goes with angle 1 and angle 2 are a linear pair. Done. I got real generic, didn't I?
Yes, please.
Because it didn't say if angle 1 and 2 were made of lines or rays or segments, so I drew as little as possible. And what will I start with to make my flow chain? Your givens. What was I given?
Angle 1 and angle 2 are linear pairs.
They are in a linear pair, so watch how lazy I'm going to get. I'm going to say angle 1 and angle 2, and I'm going to use LP for linear pair. Because I can. So y'all can too. Awesome. Okay. But now you have to start thinking. I've got a linear pair. Where can that linear pair take me?
Supplementary.
Ah, somebody remembered or looked on their sheet and saw that it implies supplementary angles. That means that up here in the top of my box, I can only say something about supplementary angles. So what can I say? No, I can't say anything about adding. All I can say is something is supplementary.
Angle 1 and angle 2 are supplementary.
Yeah, I've got a linear pair, so I can say that angle 1 is supplementary to angle 2. That's all I can say there, because that's all it says down here is supplementary. You can't throw extra stuff in there just because you know what comes next. You got to save what comes next for the next box. And so then your next box is going to start with which thing? Supplementary angles. And you're like, oh, this is why I had to memorize those ding-dang implied statements. So what do supplementary angles imply? Two angles with a sum of 180 degrees. And so you write that down, and then you start thinking, how do I write a sum?
Angle 1 plus angle 2.
Well, I write something with a plus, but can I add
Measure.
angle 1 plus angle 2?
No, measure.
The measure of angle 1 plus the measure of angle 2 has to sum to 180 degrees. Oh, he says we're done again. Are we actually done this time?
Yes.
Yes, because I have reached exactly what it asked for. Yes,
I have a question.
I can answer.
This is on the test. Do the implied statements have to be like word for word, like on your paper, or like if you get the
Word for word.
idea,
No,
like,
word for word. You have to memorize your implied statements.
So basically the bottom part is,
It's gonna make a billion.
The bottom part is the stuff straight off your implied statement sheet.
and then the top part is just applying.
Applying it to the specific stuff.
Will the top part be word for word too? Or can it be like kind of...
Well, that one, yeah, like here you might have said angle 1 and angle 2 are supplementary. It's a different way to say the same thing. But the implied statement should be exact. Okay, good question. All right. So, in general, y'all, I'm going to skip example 3 because it's another short one that you already know how to do.
Yeah.
Okay? In general, you're going to always start with a given and your given thing. And then you say, okay, where did that implied statement lead? And wherever it led, that should be the thing that's on top there. Whatever was on top here should be the first thing in your next implied statement. And it's going to lead to some new conclusion, and that new conclusion better be the thing that's on top of it.
Wait.
Oh, it's only 3?
Well, it could, etc., 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 etc. And of course, yesterday, sometimes we ran into dead ends, and then what did we have to do?
We had to go restart.
We had to restart and make a new chain and link our chains. Turn the page. We'll turn the page. Before we get to the double chain, guys, focus on example 4 for a second. The pretty picture is already drawn. What's given?
The picture.
Figure. What, go figure? What does it mean when it says figure?
A figure.
It means whatever you've got in the picture is what you're given. So, what things can you get from a picture? What things can you imply directly from the picture that you can trust in the picture? Yes, what do you got, Quentin?
Linear pair.
Linear pairs, AJ? No, I can't get, I can get vertical angles, a linear pair, what else can I get directly from a picture? Adjacent angles, what else can I get? And between this, that's up here.
Oh, I get candy.
Obviously not.
No. So you have to memorize those things you can look at in a picture. Shh. Do I have linear pairs in this picture?
Yes.
Do I have vertical angles in this picture?
Yes.
Do I have adjacent angles?
No. Yes.
Yes. Linear pairs are always adjacent. Do I have betweenness showing up? No. So I have 3 possible things I could see in this picture. How do I know what to start with as my given?
You look at what you're trying to
You just pick one.
No. You look for where you're aiming. I'm trying to prove angle 1 has the same measure as angle 2. And then you go look at the picture and see where 1 and 2 are. How are they related? So should I maybe start with vertical angles?
Yeah.
Yeah, see, common sense here. So what will I say?
Angle 1 and
Angle 1 and angle 2 are vertical. So angle 1 is vertical to angle angle 2.
That's your given.
And that's my given, because it's given in the picture. And you can just say given, but for my people at home, I'm going to put given in the picture so they know what the heck I'm talking about. Now, where do I go next? What goes in my next box now?
Well, the implied statement.
The implied statement. What will my implied statement start with?
Vertical angle.
Those vertical angles. And you have to think about what those imply. Congruent angles. So which angles should I say are congruent in this guy?
Angle 1 and
The ones that were vertical. So angle 1 is congruent to angle 2. And then you get to draw a cute little box. Make sure that your writing is legible, because the teacher grading this on your test, if they can't read it, they'll just mark it wrong. So those of you who are used to doing chicken scratch, if I can't read it, I'm not trying to interpret it. You have to take the effort if you want the grade to make it so I can read it. Okay? Cool. Am I done?
No.
Darn it. Nope, I've said they're congruent, but I have to say that their measures are equal. So where can I go now?
Congruent angles equal.
Congruent angles implies equal measure of angles. Practice writing the M in front of the angle sign. It's a good habit to get into.
Now we're done.
No, I'm not.
No, we're not, Sean.
I still have to put the stuff on top that goes
Once
there.
you do that, you're done.
Well, okay, so what goes there?
Measure of angle 1.
The measure of angle 1 has to equal the measure of angle 2. Will learning to write your symbols mean you can write less?
Yes.
Yes, that's why mathematicians use so many symbols, because we're lazy. I don't want to have to write a 50,000 word essay. I want to write as little as possible. And so I can read this out loud. Angle 1 is vertical to angle 2, which is given in the picture. I can say all this stuff with the big words, but it takes less time to write, because it's shorter.
Yeah.
Yeah. Then example 5. So, what's given?
Angle 5.
Angle 5 is congruent to angle 6.
Angle 5 is congruent. Now, anytime they give you stuff's congruent, what should you do? Mark it in the picture. So angle 5 and angle 6 are congruent to each other. Are they adjacent angles?
Yes.
No. They don't share a ray. Are they vertical angles?
No.
No. They're just two random angles that we have been told are congruent. And if we get told it, it must be true, because it's given. So I know these guys are congruent. What am I trying to prove?
5 and 7. 5 and 7 are.
I'm trying to prove 5 and 7 are congruent. Are 5 and 7 related in any fancy way?
No.
They're not related either.
7 are vertical. And then vertical angles are
Okay, so I know
congruent angles.
I had this congruent, but y'all said I had vertical angles, so it sounds like I'm going to need that to be a given as well. So it sounds like we're going to have 2 chains. So let's start with the given that we're given. So let's start with the angle 5 being congruent to angle 6. That's a given.
Angle 6.
Does this look like the face of someone who would be kidding you?
Angle 6 is equal to angle 7.
Okay. Now I know 5 is congruent to 6. What do congruent angles imply?
Equal measure.
Am I going to need equal measures? No?
Really?
So this is kind of a dead end right at the beginning.
Crazy.
So, what do I do when I reach a dead end?
Continue making it.
You start a new chain. What do you think is the new chain I'm going to start with? Those vertical angles you were thinking about. So I can say that angles 6 and 7 are vertical because it's given in the picture. So now that 6 is vertical to 7, where can those vertical angles lead me to congruent angles. If 6 is vertical to 7, what's congruent? 6 and 7. So angle 6 is congruent to angle 7. Drawing the box really helps you keep it together and things don't start to run together. It's a little more organized than just having the loose chain that we did last class. That's why we draw the flow boxes. Okay? So I have 6 is congruent to 7. Well, what do congruent angles imply? Do I need equal measures?
No. Yes.
Darn! I'm at a dead end again. I've got 6 is congruent to 7, and I've got 5 is congruent to 6.
Now you do like connect them.
I need to connect my chains. What are the most common ways of connecting the chains?
In the middle.
The transitive property and the substitution property. These are going to be the most common two. For transitive property, you're going to look for two things that both equal the same thing. Do I have two things that are both equal to or congruent to the same thing?
Yeah.
Yeah. Both of these have a 6 in them, but one of them is a 5 and one of them is a 7. So if they're both equal to 6, you can skip the thing they're both equal to and connect angle 5 congruent to angle 7. But I have to take this arrow and point it down there so that the chains get connected. And what property says two things equal to the same thing or equal to each other? And which transitive is this going to be?
Property of congruence.
Property of congruence, because I have a congruent sign.
POC? Yeah, what is POC?
Property of congruence. Okay, how you feeling? Okay, let's see if we can figure out a pitfall then. Try the next guy. Well, start me off. Tell me what to do. What does the given even say?
Ray OA perpendicular to ray OB.
So they're perpendicular. So perpendicular, you can put that little perpendicular sign in there.
Perpendicular.
And what am I going to try and prove?
The two angles add up to...
That the two angles add up to 90. So somewhere I need to get 90 into this picture.
It's a right angle.
Somewhere I need to get angle 1 in here. And I need to get angle 2 in here. All of those have to be brought in somehow.
Bisected.
What do I start with? No. What do I always start with?
Given.
Given. I am given OA is perpendicular to OB. And what does perpendicular rays imply? What does perpendicular anything imply? Perpendicular implies right angle. And I will allow you to leave off lines or rays here and just say perpendicular implies right angles, because it might be perpendicular rays, it might be perpendicular lines, it might be perpendicular segments. So you can just say perpendicular implies right angles and I will accept it. So here are my perpendicular things. What needs to go over here now?
Measure.
Some kind, no.
No, it'd be like...
The only thing to put there is something is a right angle. What is the right angle?
Angle AOB.
Angle AOB or angle BOA. It doesn't matter which way you say it.
Right angles equal 90 degrees.
No, they don't. What do they do? What does right angle do?
Congruent.
It implies what?
Congruent angles.
No.
Sums
add up.
Congruent angles.
Some equals 90 degrees.
No, that's
Measures the angles.
the measure of the angle equals 90 degrees. Yes, I need that in there to count it correct. Because that then tells you exactly what to write on top. I had a right angle, so I need to put the measure of some angle. Which angle?
AOB.
Whoa, angle 1, angle 2, or AOB? The one that you had over here is going to be the one here. So the measure of angle AOB is equal to 90 degrees. We learned them this way for a reason. And you didn't like it. You're like, I just know it equals 90. Put the whole thing. It tells you what to do. But I don't want the measure of angle AOB to be 90. I want the measure of angle 1 plus the, how am I going to pull those guys in?
We have to do the complementary.
I need to somehow get them in, so I'm going to have to start a new chain. But that means I need a new given. What can I get from the picture here?
Angle 1 and angle 2 are adjacent.
I can get those adjacent angles. Because that's something you can pull from the picture. So I can say angle 1 and angle 2 are adjacent. That's given in the picture. I just looked and said, how am I going to get angle 1 and 2 in? Well, I can see they're adjacent. Boom, there they are. But now that I know that I have adjacent angles, where does that lead me? What's AAP mean? Angle addition. You can still just write AAP, but I'm just checking to see if you know your words. Now, what does the angle addition postulate look like? Part plus part equals whole. What are my two parts? No. The measure of angle 1. Well, I was shaking my head at someone who didn't. Measure of angle 1 plus the measure of angle 2. Do I get to add them up to a number? No, I have to say the name of the angle they combine to make. And what is the angle that angle 1 and angle 2 add up to? I could say BOA or AOB. Should I maybe match it to what I've already been using? So that it's always consistent through the problem? Anytime you repeat something in a problem, try and name it the same way, because that helps you when you're ready to start looking for things in common to visually see that you're talking about the same guy. So now, I've got angle 1 and angle 2 down here. I've got my 90-degree angle up here. How do I get it all back together?
The AOB, you take
How do I know I can use it? How do I know I can use the transitive property? Yes, go ahead.
you take the AOB from both of them, and if AOB equals 90, then the AOB in that equation should equal 90.
Yeah, they both equal AOB. I have two things equal to the same thing. And so that same thing can mysteriously disappear, and I can bring my boxes together. So now, that measure of angle 1 plus the measure of angle 2 that was down here can get connected to the 90 degrees up there. Transitive property in action. But so what do I write?
Trans POC.
Is it POC? It's a property of equality because it has an equal sign. Feeling a little bit better?
Kind of.
Maybe, kinda, sorta? Okay. Try number 7 without me guiding you through it. Try number 7. It's nice and short. I believe in you. Work together if you want, but be working.
How do you do bisect?
You can either write the word bisects or the symbol bisect. Remember when you bisect, you cut something in two? You cut it in two. I did the first box for you. Aren't I helpful? It's so helpful to know the givens. But then you get to the next block and you're like, great, now what do I do? So you're probably going to think that, oh, I have a bisector. I'm bisecting a segment. So I know that I have a segment bisector needs to imply something. And so what does a segment bisector imply? And a lot of people are going to want to say that it implies congruent segments. But it doesn't. It implies intersection at a midpoint. And so now you think, okay, J bisected it. That's the first half. So up here, I need something about a midpoint. And the only thing I know is that my midpoint is named A. So I can say A is the midpoint. And now that I have A as the midpoint, I'm going to come here and think, where does my midpoint lead? And a midpoint implies two congruent collinear segments. And so then you think, okay, what will be my congruent segments up here? If A is the midpoint, then those should be the congruent parts. And so that's going to be segment CA being congruent to segment RA. Okay, I'm done. Compare yours to mine.
You got it right.
I got it. I got it right.
I got the answer.
I feel awesome.
Now check your implied statements. Logan, don't die. You need a given in your first one, and then you pulled the segment bisector from the first box, and that's going to lead you to an intersection at midpoint. And then that intersection at a midpoint, or just that midpoint, should imply that you have two congruent collinear segments, which happen to be the ones you are looking for. How many people pretty much got it right all on your own?
All on my own.
Okay?
All on my own.
Wonderful! You won't be able to do the next one.
Oh. You would. I mean, most
So, on the next one here,
I knew the given.
find your given, mark it in the picture. Run example 8. So I'm given angle 1 and angle 3 are congruent. Now,
Now they're equal.
now look for what you're going to try and prove.
Go get your candy. Wait, I found a mistake. You said something wrong.
I am trying to prove
No, they imply.
that where's QPS? It's this whole guy. I'm trying to prove QPS, its measure, is equal to TPR. That's this guy. I'm trying to prove those are congruent. So somehow, I'm going to have to go from knowing that angle 1 and 3 have equal measures and get to QPS and TPR having equal measures. I've got to get TPR in the picture. What's TPR made out of? 2 and 3, I haven't even talked about angle 2 yet. What's QPS made of? 1 and 2, I still haven't talked about, somehow I'm going to get number 2 in here. So I'm going to have to pull in some stuff that they didn't give me. Where am I going to pull it from? The picture. So let's see where the given leads us, and then figure out what I can pull from the picture. So I'm given the measure of angle 1 is equal to the measure of angle 3.
Angle addition.
That's given. Now, what do equal measures imply?
Congruent.
Oh, congruent angles. Do I need congruent angles anywhere?
No.
So that's kind of useless now. I have dead-ended. Because the only place these things being congruent can lead currently is to congruence. And I don't want congruence. So now I need to find something else in my picture. What else is now in your picture that you can see?
Angle 1, angle 2, and angle 3.
Which things do you want to say are adjacent?
Angle 1 and 2.
Angle 1 and 2 are adjacent. Let's just do one thing at a time. So angle 1 is adjacent to angle 2. That's also given in the picture. Keep it simple, y'all. Is that something that can imply anything else?
Yes.
Yes, so I'm going to go ahead and see where it leads. Adjacent angles have to imply something else. So you look on your implied statement sheet, or you remember that it implies angle addition and the postulate. So now you have to think, if I have 1 adjacent to 2, angle addition postulate says to add some angles. What am I going to add? Measure of angle 1 and the measure of angle 2, but what will they add up to? Which measure?
QPS.
1 and 2 add up to QPS, and I'm going to write it as QPS and not SPQ so I can match the thing I'm looking for. So the measure of angle QPS. I have got QPS in the problem. I brought it in. I can't solve it unless it appeared somewhere. I have now made it appear. I am happy with that. So now that I have these added up, where does that lead?
Do the same thing with 2 and 3.
I can't do anything there, so you go, okay, I'm going to go back. Can I do the same thing with 2 and 3?
Yep.
Yes, they're also adjacent. So let's make a chain with angle 2 adjacent to angle 3. Wow, a 3-chainer.
That is crazy.
We're getting wild here.
Gonna solve that one.
So once again, you have adjacent angles. So Cole, what do adjacent angles imply again? AP. So I'm just going to do the same old guy again.
Let's go.
But now what things am I going to add?
Measure of angle 2.
2 and the measure of angle 3. And what angle do they add up to?
RP.
I could say RPT, but since it asks for TPR, I'm going to write it as the measure of angle TPR so that I'm writing it the same way it asked for in the proof. That way at the end, you're like, wait, did I find what I was supposed to find? If you've already written it that way, you don't have to wonder later.
Are we not one like this on the test?
Are we done? Have I proven QPS is...
Like, if it's the same in... Oh, shit.
Okay. Now, I want to try and bring stuff together.
Transitive property.
And I would love to use the transitive property, but are these two things exactly identical? No. If they were only identical, but one of them has a 3 and one of them has a 1. But, exciting movement says that I can replace something in this guy to make it match this one. So they already both have a 2, but the red guy has a 3. So could I replace the angle 1 with something else?
The 3.
I can replace it with the measure of angle 3. So I'm going to bring over angle 3 and drop it where angle 1 was. And then I'm going to keep going. What property let me replace just angle 1? Did I have 2 things equal to the same thing equaling each other?
No, substitution.
I just replaced one thing, so this is substitution. And it's a POE, you're correct. Now, do I have 2 of the exact same things being added together here? Yeah, 2 and 3 added is the same as 3 and 2 added. So I have 2 things both equal to the same thing. So I can skip the things that are the same and bring what's left behind together. What should I write first? Should I write TPR first? No. I could, but if I had it written first, I'd have to take a whole separate step to flip it back around. And so to save myself a step, I'm going to write it the way it's written when it's asking for it. So I'm going to start with my measure of angle QPS and say it's equal to the measure of angle TPR. And that is transitive because I had two things equal to the same thing. I took out the same thing and now they're equal to each other. And it will be a property of equality.
Wow.
Oh, y'all thought that was a long one?
No, stop.
Look at the next one.
Stop.
Like, are we gonna be doing stuff like that on the test?
Yes.
No.
So,
in the wrist, my
what is your test?
Wait, so is it minus just one, like, question?
So on the test, the top half of the box is one problem, the bottom half is another problem.
Oh, thank God.
So that'd be like 1 point.
Well, I don't know, it might be 2 points per part, I don't know, it depends on the test. But the top part is counted separately from the bottom.
So if it's Tuesday, the test won't count.
So how about this? Why don't we go ahead and you can start taking the time to work on the homework and ask your questions as we go so you can get lots of help while you're in here instead of me walking through one more example.
Who's they?